Hello everyone and welcome to this new part of the Allplan Basis course for students. My name is Jakob Martin and I'm your instructor for today. So in the first part we learned a lot about 2D construction, and today on the second part we will learn more about 3D construction. So again, as I told you in the last part, as soon as you start Allplan up, you can see the startup window. And I mentioned it earlier, but on the right side, you can see the recent projects. And you just have to double click on the projects that are relevant to you that you want to open. And for example, here we see the project Allplan Basis Course 1, which is stored on localhost. And I will just do a double click on that one to reopen what we've had the last time. So the first thing I want to mention and to tell you in this part of the course is that we are going to basically talk a lot about open on a project-specific basis. Why do we talk about that in general? So it has to be mentioned that last time we were only drawing on one specific drawing. In this part, we are going to use what we've created earlier to set as a reference to create more 3D elements. And I want to show that to you. So please click on this kind of button on the upper left corner, which is called Open on a Project-Specific Basis. As soon as we click on it, a new menu pops up. The current project does not have a building structure. You can do the following. We can start the building structure wizard. We can create a custom building structure. We can select a predefined building structure or use a building structure from a different project. I want you to use the button Create a Custom Building Structure. We will also talk about that in depth a little bit later on in the course. So press OK. And this is basically what will show up every time you click on Open on a Project-Specific Basis. So here we can see the name of the project itself, Allplan Basis Course 1. And here we can see the first drawing. And this first drawing is already activated. So let's go ahead and rename the first drawing. So right-click, rename, and let's name it 2D construction, which is perfectly fine. So this is one way I wanted to show you. So you can just do a right click on the number, select rename, and after that basically rename the drawing itself. For the next part, we're going ahead and we select the second drawing. And we can do one left click, so it's just marked as you can see it by me. And you can click another time as a left click, and then we can add 3D construction. So you can see it's very easy to set the names right for the different drawings. So let's go ahead and do another right click on the second drawing. And here you can see the different states that a drawing can be selected. So a drawing can be set to current, a drawing can be set to edit, a drawing can be set to reference, and obviously not selected. So what are the differences between these kinds of settings? So as you can see right now in my example, the first drawing is set to current. So basically what happens if you do a double click, and this is just another side note from my side, double click on one drawing will select only this drawing to be set as current. So just do a double click here. And there you can see this drawing I'm having right here is set to current and only this drawing. But now you can select different drawings and basically view them in parallel. And this is where the other functions come in mind. So what we can do is basically set a couple of other drawings to the edit mode. And I want to show that as well, because this can be a little bit confusing in the beginning. So when I close it, nothing really changes. But as soon as I go again on the project-specific basis, I have a couple of different drawings selected in the edit mode. And now I want to go ahead and set more than one drawing as current, and you can see this is not possible. So only one drawing can be set as current. And what that's all about, I will tell you now. So maybe for this kind of example, we will use the second drawing. It should be set to current, and the first drawing should be set to the edit mode, just like I have it on my screen right now. So what basically happens if I close it, I don't see any kind of difference that we had beforehand. But I'm now going to create new elements, and this is important. So I'm going to create this element, just a cross here in the middle, and everything looks perfectly fine. I can also access all the already existing elements that I've created, the fillings, the lines, and so on and so on. And I can now go ahead, click again on Open on a process specific basis, and click on 3D Constructions 2 times to set it as current. And now you can see that the new elements are only placed on the second drawing, which is named 3D Construction. We can also see that up here. And this is basically what happens if I create new elements. So new elements will only be placed on the drawing that is set to current. So as soon as I, for example, set the first drawing as current and input another cross just like that, and now I will only select the first drawing, you can see this kind of cross that I've placed here disappears. So this comes in really handy if you want to work in parallel with different drawings. So to be a little bit more precise and a little bit more on the safe side, we can also set the first drawing, for example, in the reference mode. And there is a difference there. So let's close it. We can see that everything that is on the first drawing is set to reference, and we can basically not edit it in any way. But still, the elements on the current drawing are completely available and can be changed. The good thing about the reference setting is that when we basically go ahead and want to place a new line, we can take the already existing elements as a reference and basically get the points from there. So if I want, for example, place a figure just like that, this is absolutely possible. And we don't have any kinds of trouble in doing that. And the good thing is we are not able to edit these kinds of elements in any way. So, for example, if you have an already existing grid, you can use the reference setting to use the points from the already existing grid, but we are not able to edit it in any way. And this comes in really handy if you work with Allplan on a real project. So this is really important, and I wanted to tell you that beforehand. So let's go ahead, open on a project-specific basis, and just use this kind of setting. So we have 2D construction and 3D construction. And now we are going to use the elements on the first drawing, which is called 2D construction, to generate more elements on 3D construction. So basically, set your drawings just like you see it on my screen. Go to close. And now we go ahead and we basically input our new elements as we can see it right here. So the first thing we want to do is now we are going to change the label. And please go on the role draft. We talked about that in the first part. Go to the label modeling. And now you can see the menu, which is called 3D objects. And this is where it gets interesting because we have a 3D line available here. And I want to show you, just before we place the first 3D line, I want to show you something that is very different from a 2D line. So I also talked about that in the first part. Let's go to the window and use this kind of setting 2+1 animation window. So click on that one. Our drawing space will change accordingly. And now let's go ahead and take a look at the central perspective, which is completely empty. There are no elements there. And there are also no elements in the front south elevation window. That is because we only placed 2D elements. So let's go ahead and start to place 3D elements. So go on the label modeling and choose the option 3D line. So we already know that as soon as we click on some kind of function up here, that basically a new menus will pop up. And for 3D line, we have, for example, the option 3D line, 3D rectangle, 3D polygon, stuff like that. And we also have the option to activate and deactivate polyline. We already know that one from the beginning. Just keep it as it is. And on the first part, we learned about the 3D line and the from point and the to point. And it's the same with this kind of function, beside that we have the set coordinate as well here. So we didn't have that option in the 2D lines, but we need it obviously for the 3D lines. But we still don't need it right here because we're using our 2D construction as a reference. So let's go ahead and just do a left click here because we are basically taking the first from point here. Then we click on the to point, which is that one. And because we have the polyline activated, we can just go ahead and place the new elements accordingly there. And just pause there for a second, don't press anything. Just take a look at the central perspective and animation window on the right. You can see that the two lines are there and you can see it there. And we also have the front and south elevation there. And we can start to see elements. So let's finish this kind of figure and press escape once. And now we can see that we have created our first 3D objects, which can be seen in the central perspective and the front and south elevation. And this is a really good thing. And I wanted to show you that because you learned how to use other drawings as a reference. And now you understand that in your drawing space, if you're in some kind of isometric view or elevation view, you are not able to see in the standard setting 2D elements. There is an option to change that. I can also show that one. But in the standard setting, it's not possible. So let's, for example, go to the isometric view and we can only see this kind of element right here. And this is really important to keep that in mind, because if you're drawing 2D elements and for whatever reason an isometric view is being activated, you're not able to see anything and you will think, okay, I opened my drawing and there should be elements there, but I can't see any elements. And one of the number one reason is that some kind of isometric view or elevation view is being activated. So keep that in mind if you open up a drawing and it's empty. Good. So that was the first thing. This is not really spectacular. And why is it not really spectacular? Because we didn't basically create a 3D object that has set coordinates, because we input the values with set coordinates according to 0. And this is the reason why it lays flat on the ground. So let's go ahead and now we have to create some kind of line that has set coordinates. And this is where it gets interesting, because normally if we basically wanted to create a pyramid, we could basically use these 3D lines to create the shape of a pyramid. So let's go ahead, again, click on 3D line, and this is where it gets interesting. So please don't do what I do now, but I want to demonstrate to you something. So I could, again, go ahead, construct a cross, click on that kind of point that I've been just created. And input the Z coordinates with 5 meters. So let's take a quick look at what we've just done. So basically, we use the cross to basically construct the first point, but we don't really need it. So what we can do is basically use this as a first point that we've just constructed and input Z coordinates with 5 meters. So just like that. And we can see the result in the central perspective. But this is not really handy. And I told you already in the first part when we were generating the circle that there are different construction options. So I pressed escape a couple of times and let's go ahead, click on 3D line again. And now do a right click. And again, choose midpoint. So as soon as you click on midpoint, you have the upper left corner and the bottom right corner, just like that. And we will basically generate the center point for the circle again. And I'm doing that because I wanted to show you something. So basically, this is the first thing we can do. And we basically generate the first point, the from point for the 3D line. So I just did a left click now, and this is the first point that has been generated. And now we can go ahead. I press the tabulator key to go to delta Z. And when we now input the value 5, it will go 5 meters straight from the top to the bottom. From bottom to top, I'm sorry. And this is what we basically want. So basically, we input the value and we press enter. And now we have basically generated the midline for our pyramid. So let's press escape for a second and let's take a look. So we can basically see that the plane that also is being generated as soon as we have 3D elements gets bigger when we place elements above the coordinate, the Z coordinate 0. So this is the first thing we notice. And now we have basically 3D elements that are being constructed. And this is a good thing because now we can use these generated 3D points to use them as a reference and to finish our pyramid construction from lines. So let's go ahead, again click on 3D line, and now it gets a little bit tricky. So the first thing I want to mention is, for example, the central perspective in the animation view type is not really handy when it comes to constructing things. Just take a quick look, for example, on our plan view, and we have the view type wireframe. And this is basically the construction mode I would suggest to use if you want to construct anything or draw anything. So let's go to the moving mode or navigation mode. So you can choose this kind of mode down here. Or you just press Ctrl and D. This is what I do. And now we can change the view accordingly so that we can work really nice and easy with it. So maybe just like that. The important thing is that you always deactivate the navigation mode again after you have changed the view to continue to work. Otherwise you won't have your cross on your drawing screen. Okay, so let's go ahead. And now we can basically use the already existing points. So we have this point that needs to be connected with that point, this point that needs to be connected with this point, and so on and so on and so on. So let's go ahead, click on the first point, and we can basically see in the front and south elevation as well as in the central perspective that as soon as we lock into the points, the right coordinates will be set. So here I'm with my cross, it's not very good, and the point lands everywhere. But as soon as we click or lock into that point, we get the results that we want. And this is a really important information. You can do your isometric construction, escape one time, just like that. And after that, you can use basically your navigation mode to look at your objects that you've just created. So keep that in mind when it comes to 3D construction in Allplan. You need to tell the program every coordinate. And if you don't do that, one coordinate will be set automatically and the result will always be false. Now it gets interesting a little bit longer because we're on the view type wireframe, but still our 2D objects are missing, even if we go to the plan view, which is not a real plan view in the navigation mode. So what we have to do is basically go down here and change the view and click specifically on the floor plan. This is kind of important. And as soon as we click on the floor plan, we can see that we have different lines and 2D constructions visible again. And we also have the 3D constructions here. The good thing is about the navigation mode will be stored according to the different windows and drawing spaces you have opened. So if I wanted to talk about the central perspective, for example, I can always keep the navigation mode activated. So this is a really important information I would just wanted to give you as well. So let's go ahead and talk a little bit more about the 3D surfaces, because this is also a really important topic. So click on the 3D surfaces for the next step. And as soon as you have activated the function, you can see we have the polygonal 3D surface, we have spline surfaces, rectangular, and so on. We will use the polygonal one. So again, what we want to do is basically use the already generated points for our construction to basically add 3D surfaces to our figure, to our shape. So let's press on Ctrl D. Again, use a really nice view that we can easily work with, just like that. And again, press on Ctrl D. So to deactivate the navigation mode. And what we are going to do now is that we are basically generating a 3D surface that will close our shape. So keep a very close eye to the central perspective while I'm working. So this is the first point. This is the second point. We are just doing a left click on it. And now I'm going ahead to the top of the pyramid. And I'm doing a left click on that as well. And now I have two options. The first option would be I just do another click on the first point I've clicked on, or I just press escape once and the first and the last point I've generated for the 3D surfaces will be connected in a straight line. And since this is the result I want, I can just press escape. And now I can see that there is a 3D surface being generated. Let's go ahead. I just pressed escape a couple of times and we can see as soon as we hover with our mouse over this kind of surface, it can be seen that only there is a surface. And as soon as I click on it, I can also see that it will be marked red, which is perfectly fine. So let's do a double right click on the 3D surface, which activates the 3D surface and also overtakes all the parameters that are set to this 3D surface. And now we will go ahead and generate all the other surfaces. So I just generated 3. Let's take a quick look in our central perspective on the top right. Okay, this looks good. And now I will generate the last one. So we can see that our pyramid now is closed. And this is a very good result. This is the result we were expecting. But there is a difference I also want to mention. And the difference is line color and surface. So let's change the line color of a 3D surface. So let's take that one, for example. Line color. And choose, for example, the line color 7. Let's take a very quick look at our parallel projection here. So we can see that the line color changed accordingly, which is perfectly fine. This is what we expected. This is what we want. The other thing is we can see that not only the line color, but the color of the complete shape is being changed into the central perspective. But this is very different from the surface I want to show you right now. So you're able to basically change the surface of any three-dimensional object. So that is not a line. So let's go ahead, for example, do a right click in the navigation mode in the central perspective on our blue 3D plan. And then we can basically click on Assign Custom Surfaces to 3D or Architectural Elements. So just click on that one. And now we can go ahead and basically use the Surfaces menu to choose a really nice surface. So for example, let's go to Office. Let's go to 30-year edition materials on the next step and choose something, for example, exposed concrete. It doesn't really matter what you choose. So let's use that one. And you can see that the surface changed in our animation view. But the line color is the same as it was beforehand. And you have to keep that in mind, that this is different. For example, again, let's use that surface and use a line color, for example, 5. Okay, perfectly fine. And now go ahead, right click, Assign Custom Surface, not Project, Office, I'm sorry, and use, for example, Transparency. And choose a very different one. So the greenish one, for example. So you can see that the color of the surface is not dependent on the line color that we've just generated. And you have to keep that in mind. This is really important because this can cause trouble during the project if you don't understand that. Okay, the next thing we want to do is we assign custom surfaces to all the different 3D plans that we've generated. Materials, I will choose something like that. And choose something like that. It doesn't really matter. It's only important that they are different, and this is perfectly fine. So this is basically what we've done. And this is our pyramid. And I will also talk a little bit more about the cone and pyramid function as well. But this, let's give it some time that we talk about the 3D surfaces at first. Okay, so let's continue with a little bit more complex function that also could come in really handy if we're working with different 3D objects. So let's go to the edit mode. And for example, I expanded the menu. I also talked about that one in the first chapter of our course. We can basically use this drop-down menu and use rotate 3D elements or access this via expanding the menu and click on rotate 3D elements, just like that. So rotation in the 3D space is not that simple. And our goal is to basically rotate these 3D surfaces outwards and basically rotate them in our plan that we can see here, the grayish one. So I will click on this 3D surface. And the first question, or to be precise, the second question Allplan asks us is, it wants to know the first point of the rotation axis. And since it should be rotated completely on the space line, we can click on the first point, just like that. And after that on the second point. And now we could go ahead, I just want to demonstrate it to you, and basically input angle of the rotation. So let's put, for example, 30 degrees, just like that. And there it is. Since we don't know exactly the angle of rotation that we need to basically put this 3D surface in our plan, we can just press Ctrl Z and just use a different function. So again, rotate 3D elements, 3D surface, first point of the rotation axis, second point of the rotation axis. And now we don't go ahead and input any kind of value here. We just click on the tip of the pyramid. So just like that. And now we can see that the tip of the pyramid from the 3D surface is locked to our cursor. So let's go ahead and basically rotate that one outwards. And this is where this front elevation comes in handy, because we always need a view regarding the rotation that is perfectly fitting to what we want to rotate. And since we want to rotate it in the plan, just like that, and you can see nothing is locked there, we will talk about it in a second, this kind of front elevation comes in really handy. So what we're going to do is we hover over, for example, that point. And as soon as you keep your cursor longer than 1 second there, you have a track line that is being connected. And as soon as we go into the plan with this kind of surface, just like that, we will catch the track line. And as soon as we do a left click, we can see that this kind of surface is now put outwards and exactly in the plan view. And we can basically do that for all the kind of surfaces. So let's do that one again. 3D surface, first point of rotation, second point of rotation. So, and now what we can see in the front or south elevation, we have the problem that we don't really see what's going on there. We don't really see the rotation since this is being rotated in our view itself. So let's change the view, for example, to the west elevation. And there we have the view, which is good. So hovering 1 second over this kind of point, going outwards, use the track line, and there it is. And we can see we have some glitching right here, which is perfectly normal because we have two surfaces that are in the exact same height as the other. So nothing to worry about. Let's go ahead, rotate the third one, just like that. Choose a different kind of view. Use the track line, just like that. Okay, let's go ahead and the last one. Sorry. Just like that. First point, second point, tip. And after that we go outwards and use the track line. And there we have it. So this is basically what we wanted to create. So we also talked not only about how to create 3D lines and this kind of 3D surfaces, we also talked about how to rotate these kinds of surfaces because this comes in really handy. So let's go ahead and talk very quickly about the cone and pyramid function. And this will generate basically a solid. So what you can do is basically you can click on a closed surface and this will basically generate this kind of object as we can see here. But this is a solid and this solid, for example, cannot be easily just rotated and changed as we did beforehand. So this is the reason why I wanted to show you earlier. 3D objects are very different from 3D surfaces and 3D polylines or lines in general. So there is that. So let's generate another solid. Let's go ahead, for example, and use this kind of box. So you can do that in parallel with me. I will also go to the plan view to make this a little bit more easier. Click. Start point, delta x 1 meter, delta y 1 meter, delta z also set to 1 meter. And there we create a cube. So just like that. So delta x 1 meter, delta y 1 meter, delta z 1 meter. Press enter. And now we can see that we've created a solid that is a cube. I also want to talk about the Boolean operators, which are kind of important. But first, before we talk about the Boolean operators that are more or less mathematical functions for solids, let's go ahead and generate a cylinder. And the first thing we want to generate is the midpoint. I use the track line just like that. And there we can input the radius, which should be set to 0.5 meters. Why 0.5? Because the diameter should be 1 meter, which seems like very logical. 0.5 meters as a radius. Enter. Point on parallel cylinder or surface height. So we input a height of 1 meter. And press enter again. And now we can see we've generated a cube and generated basically a cylinder. So our goal here is to basically add another cylinder exactly inside of the cylinder. Why would we do this? Because we want to create some kind of pipe. And the pipe should have a thickness of 10 centimeters. So how do we do that? So we are going to generate another cylinder inside. So what I did, just do a right click on the edge of the already generated cylinder. And as soon as you click on midpoint, it will automatically catch the midpoint of the already generated cylinder. Input the coordinate delta x 0.1, and the thickness of the pipe will be set to 0.1 meters regarding that. Press enter and input the height of 1 meter. So the good thing here is that as soon as we work with that, is that we have two objects inside of another. And what we can basically do is we can now use the Boolean operators that you can see here. I already expanded that as well. So just do a double click on Boolean operators. We can, for example, then subtract and retain solid. Or we could use, for example, subtract and remove solid. So we can use that one. And now take a very close look in what Allplan asks us to do. So for example, click on the first solid, properties apply to the resulting solid. Okay, let's do that one. Cylinder, outside. And now we can select one or multiple solids that are in some kind touching the first solid. So let's use that one. And now you can see there is a cylinder inside of a cylinder. Do right click, and now we basically subtracted the second cylinder from the first cylinder. So please keep in mind, this is really important, that you basically use this kind of function to subtract one solid from another. And now we can also go ahead and combine the already existing elements and make a really funny sculpture. So we can go ahead, use the move function, and now we have basically two options. I also really like to use the elevation view. So we can basically go ahead, use this kind of edge, and basically place that one on the already existing cube. Oh, I'm not very precise with that one. Just like that. And just like that. And I just why did I choose the elevation view? So beforehand, and I will undo that, you can see that these two objects are in the exact same height on one of each other. If I would have done that in our plan view, the following would happen. So the cylinder would be just inside the cube. If I'm doing that with the elevation, I'm telling Allplan all the coordinates it needs to know. So the height and also the length and the width that we want to move our object. So just like that. And this is what we want. So we want the cylinder on top of the cube. Okay, so since we want the cylinder on every part of the cube and every side of the cube, let's go ahead, for example, press copy and paste, copy the cylinder outwards, and now it gets interesting, just like that. And we already learned about that one. So let's use rotate 3D elements, use this general object, just like that. And now we can use the angle of rotation and set it to 90 degrees. And since I'm clicked first on that edge and after that on that point, I should not put in 90 degrees, but minus 90 degrees. Just like that. And this is where it comes really handy, because as soon as I have one of the objects in the space I want it to be, I can basically go ahead and use the copy and mirror function that we have learned in the first part and just mirror these kinds of elements just like that. And we can also copy and paste this kind of object just like that. And now we have the pipe on every side of our cube. So you can see how easily you can move around and generate 3D objects that are relevant for your construction. Please keep in mind that these elements are general 3D objects and are not the same as architectural elements. I will also talk about that in a second. But first, since these are separated elements, let's use the union function just like that. Just like that. And now we will basically click on every element that we see here. And as soon as we've marked every element, we can just do a right click on an empty space. And now this is a complete 3D object that is connected. So let's go a little bit ahead and also let's change the surface on that one. So assign custom surfaces. Let's take, for example, this exposed concrete. And there you can see that with round surfaces, there are some issues introduced. So this kind of surface doesn't really look too well on this kind of object, but there's a workaround. So for example, if you click on the 3D general object that we see here, we can also go to the properties. And for example, we can change the visualization. The mapping is currently set to cylinder, but I could also set it to cube. So it will just be generated newly. So let's demark it just like that. And now it looks way, way better. I could also change that to, for example, wall, which looks not that good, to be honest. I like cube much better. Just like that. So I hope you enjoyed that kind of part of course from my side. If there are any questions, feel free to contact us and see you again on part 3. Bye bye.